Hey guys, in this video we're just going to be talking about remotely controlling your FPP. Someone this morning posted a question about using the NES Power Glove to control their show, which is a pretty good idea. It kind of brought back memories of the Power Glove, but it got me thinking about controlling a show remotely. Normally I usually just use my mobile phone and I connect to the server that FPP runs on my network and I just change stuff there. But his idea was kind of having a just simple button presses to do certain commands, say like skip a song, jump backwards and forwards, or run tests or whatnot. And it got me thinking about the REST API and using an ESP board, which could be an ESP32, an 8266, could be a 32S2, S3. It doesn't really matter as long as it's got the Wi-Fi capabilities and the GPIO points that you can manipulate to send commands. And then obviously if you're running FPP. Now, if you've got FPP connected to your home network, it's already running a REST API server, so you can send API commands to it on port 80. So there's nothing really you need to set up in FPP to do this. It's already running. This could be on a Raspberry Pi, this could be on a computer, it doesn't matter, as long as FPP is running and it can receive commands or HTTP posts. So if you can use a web page to access it, you should be able to post these types of commands. In this example here, I'll just be using a Pi cap on top of a Raspberry Pi because this is the easiest way to test it. You don't need these. Like, again, this could be running on a computer or whatever. This is just to show an example here, and I'll be using a ESP32. And again, like I said, you can use any ESP as long as it's got Wi-Fi. The wires here are just to simulate button clicks, and I'll be just grounding them out on a GPIO there. So when I touch these, it's literally just a button click. Now we're going over here to FPP and the REST API in FPP. If you want to know the commands and all of that, you have to click on Help and then go to REST API Help. And in here you're going to see all of the different commands. So this is going to basically give you information on how to use these commands and what you need to send to the server to make FPP respond. So for instance, if you wanted to reboot the system, you can send that command. If you want to shut it down, you can send that command. There's a few different, as you can see, there's a few different commands. So if, for instance, you can send commands here. So if you go down to API commands here, if you just send that through a browser, it'll return a list of commands that you can actually send on the API. So it's a little bit detailed, but this is where your information will be to decipher what you need to send to FPP to make it respond. I'm not going to go too much into this. This will be a learning curve for you, obviously, but all of the information's here anyway. So I'll just go back to the status page. Now in this example, my playlist is called Show, which will be here, and this is just the sequences. These are from my wings. So when I send these commands, it'll be set up as Show as the playlist. So now we'll go here to my GitHub page. Of course, I'll include this in the video description, the link to this. So we'll just quickly explain this here. So in here, you've got your Wi-Fi SSID between the quotes. This would be your home network's Wi-Fi access point, and then the password for that access point. This here is the Wi-Fi host name is just to identify the ESP32 on your network. You don't really need to worry about changing that. And this here, FPP host IP, is the host name or the IP address of FPP on your network. This is where you're sending the commands, so you must make sure this is correct. Now here we're defining the buttons. So what we're going to do is we're going to define button 1, 2, 3, 4. in this example, but we need to define them to a GPIO on the actual ESP board. So this is where you're going to decide which GPIO numbers you're going to use and how you're going to define them. So in this example, I've just got 4, 16, 17 and 5. They're the buttons, the GPIO points I should say, and then that's the buttons. And then the setup code here, this runs once each time you boot the ESP. So what we need to do in here is we need to pull the GPIOs high so we can detect a low state. So when you press a button, it'll pull the GPIO low, and then that'll allow the software to detect that it's low. This is honestly the best way to do this, and the way to pull it low is just simply applying ground to the GPIO. Everything's high, but you're going to pull it low to indicate that you're pressing a button. And again, here you're setting button 1, 2, 3, 4 and your input pull-ups. And then this here is just your Wi-Fi connect code. You don't need to really worry about that. And then you come down into the loop. Now the loop code just runs over and over again. So what it's going to do is it's going to look for the low state on each GPIO. And then if the GPIO is pulled low, it's going to jump into that function and perform it. So in this case, the string playlist here, as I mentioned before, mine's called show. So I would replace playlist name with show. And then what this command here will do is it'll start playing my playlist. And then this command here will just play the next playlist item in the currently playing playlist, and then the previous, and then this will just stop any playlist playing. So this is just an example of some button clicks so you get the idea. And now we'll move on down to a couple of examples here that I've just put. So in these examples, these are the get examples, and then you've got post examples. The difference between get and post is the get examples, you're just sending a simple command. You're not sending any data with it. So that can be basically stop, start, next item, previous item, stuff like that. So in this command here, you'll be playing a sequence by name. This will be the file name of it without the extension. So you take off the FSEQ extension and just play the first part. So if I was to go back to here and I wanted to play that sequence, I would just play blue button. And then that's where it'd be anyway. So, and stopping a sequence, you just send effect stop, and then start the playlist name here, so you'd replace that. In my example, that would be show, and then start, and again playlist stop, so that would stop any currently playing playlist. You can pause it, resume it, or stop gracefully, and other commands. You can also play the next item or the previous item, which my buttons are set up to do. And then this is just test stop. This is for these commands really, which we'll get into. So the post commands are sending the command, so it's API command, and then you're sending a data packet with it as well to indicate what you want FPP to do. So in this case, we want to tell it to start a test, but we want it to do RGB cycle type test, and then we're going to do the color order of RGB, and then the channels that we're playing on. So what this basically is doing is it's not only sending a command, but it's also giving arguments on how to operate. We could change just the bars or whatever it may be. So this is more complicated. As you'll see here, I want to change the volume, and so I'm setting the volume at 34, and that's how you post data to FPP using a REST command. So these are a little bit more advanced over these. These are just going to be very simple: start, stop, next item, previous item, stuff like that. Now you can come back to this in the functions H. You don't need to modify anything in here. This is just code that I've put together to send the commands to the server. So here's just URL and code. All this does is remove some of the characters that are going to screw with your posts, and then just your post and get commands. So you don't need to worry about those. Your main interest is in here, and like I've just explained, so you just worry about that. So we'll go back here anyway, and what we're going to do now is we're going to simulate some button clicks. So this wire here, which would be my white one, this is set up to start the playlist, and I'll just ground it out on the GPIO. So we'll just ground it out, and that's going to start the playlist. So now we're playing the blue button sequence, and then if I want to jump forward a sequence, I've set this up to this button, and now I want to jump forward to the next sequence in the playlist, and now it'll jump forward to red button, and I can do that again, jump forward to the white button, and there you go, it's playing the white button. So now if I want to go back, I've set this up to previous, so I can just press that and it'll jump back to red button. And so it's fairly simple. And then this one here, I've just got it set up to stop, and that'll stop playing the playlist. So again, it's an example, and you'll see this is literally just button presses. You could build a controller which could do this, and you could mount it to a glove if you wanted to, and build your own NES Power Glove using this. The problem with the NES Power Glove that the member originally posted is that it has its own logic in it, and you would need to decode that logic and work out which buttons are being pressed. And yeah, that's a little bit more technical, and I'm sure someone could probably do that with some time, but you would also need a glove. I don't have one, so I can't really do that. So the best I can do is say use this setup and rebuild the glove yourself with a 3D printer, some buttons, and yeah, kind of go from there. Anyway, I hope this helps you navigate with the REST API to control your show. I think what I'm going to do myself is I'm just going to set up a little controller with the ESP to run the test modes, because when I go out to set up my show, I like to run the bars back, sort of horizontally and vertically, so I can make sure that everything's situated right. And then if something's not right, I can flip it, move it, whatever it may be. But when I watch the bar, I want to see the bar go across the entire house correctly and then up and down correctly. So I would normally do that with my mobile phone, but thanks to this member, it got me thinking about this. So I think what I might do is I just might make a simple, say, 4-button controller that's going to make bars go backwards and forwards and up and down, and then stop testing. And then that way I won't actually need to pull my phone out and mess around with it. I can just click a button and she'll be done. But anyway, I hope that helps you out explaining this kind of stuff. And yeah, see you on the next one.